Okay, welcome everyone. Thank you for joining us for WisDOT's DB Summit today, virtually. As you may or may not know, but tomorrow is our live in-person session, so hopefully we'll see a lot of you guys there. Unfortunately, we won't have the pleasure of seeing these two gentlemen live tomorrow because they're across the pond, as they would say it. My name is Meenal Ham, and I'm the president of M2 Engineering. You're currently attending the Intelligent Transportation Systems, the Future of Mobility session presented by members of WSP. For those of you that may or may not know, WSP is an international engineering firm that serves the transportation industry as one of their sectors. And they are one of the leaders of the forefront of the technology for intelligent transportation systems. So today we have Tom Gramslaw and Axel Kapler. I'm not sure if I said your name right, Axel.
That was pretty good, yes.
Okay. So I'm going to let Tom introduce you guys and go ahead and get going. But one quick note about housekeeping. So if you guys have any questions, please use the chat button to type them in, and I will be moderating and monitoring the questions as they come through. And then towards the end, we'll take a crack at answering all of them for you guys. So with that, Tom, take it away.
Brilliant. Thank you very much. Thanks everybody for dialing in and listening to us today. It's a real pleasure to be presenting to you guys across the pond, like you said, Meenal. My name's Tom Gramslaw. I am an associate in the WSP UK business. My current roles are technical lead for our digital roads program, as well as the head of connected sites within our SMP alliance here in the UK. Axel, if you could quickly introduce yourself.
Yes, sure. Good evening from Manchester in the northwest of England. My name is Axel Kapler. I'm a technical director in WSP, and I work on all things to do with road safety and trying to make our roads safer and reducing the number of people get killed and injured on our roads.
Brilliant. Thanks, Axel. So very, very quickly, what we're going to present to you today. So 3 parts to the session today. The first, part 1, will give you an introduction to digital roads, a brand new vision in the UK for our strategic road network that leverages data, connectivity and technology to really drive better outcomes and enhancements to the road network. Part 2, decarbonizing transport through ITS, that gives an introduction to a recently published white paper on how ITS can contribute to the decarbonization of transport. And part 3, Axel will talk us through the connected autonomous vehicle safety and some of the work we've been doing around safety case work in relation to adopting CAV within road networks in the UK. And then, like Meenal said, we've got questions and any form of discussion towards the end of the presentation. Just a quick note, unfortunately, my colleague Annika can't make it today, so I'll pick up on part 2 and present her slides on behalf. So without further ado, digital roads, part 1. So digital roads harness data technology and connectivity to improve the way the strategic road network is designed, built, operated and used. So what does this actually mean? So what we've got within the UK is a hierarchy of our road network, from local roads all the way through to what we call motorways. I'm assuming that's probably freeways in the US or something similar. And what we've got is a network operator that looks after the highest priority roads within the UK. Within England, it's National Highways, and they're an authority that look after the motorways and the strategic A roads. And a couple of years ago, they recognised that a significant future trend, one that's with us today, but also will take us on a journey over the next number of decades, is digital. And they wanted to explore what digital meant from a road network perspective. And at that point, digital roads as a concept was born. So digital roads is all about how we can make better use of network data, use that data to create insights that allow us to improve the way we build, improve the way we operate, and improve the way we provide customer experience. How we use technology and connectivity to get there as significant enablers was also a key part to this. And they recognized that digital has an implication across the whole life cycle of the strategic road network. So like I mentioned, all the way from design and construction through the operation and maintenance phase into how customers interact with the network and how they use the network. And there was born 3 core themes of digital roads. And I'll talk you through each of them in a little while. I think the presentation slides we've made available, so I'm conscious you probably can't read this on the screen. But what the diagram starts to show here is how digital roads will impact each stage of that life cycle. So like I say, right at the front end, improving the way that we use data and connectivity to improve the design process.
Tom,
so making you
Tom,
sorry, we're still stuck on the intro slide.
Yes.
Oh, are you? Okay. Sorry. Let me just share my screen again.
Yep. You might just have to manually move through it, or you might just want to go to presentation mode. I'm not sure if that'll work.
Can you see if I move across one slide now?
We see the main slide, and then on the left is a slide summary.
Right. Okay. Let me go back to this this slide. Can you see the slide on the screen now?
Yes.
The digital road slide?
Yes.
Yeah.
I'll present in this mode then. It's probably the best one. It doesn't seem to be working in presentation mode.
Thank you.
So like I say, there's a diagram on the screen. Unfortunately, you won't be able to read the content, but what the diagram starts to show is how digital roads will have an impact from design, better use of data, improved connectivity on the existing road network that can inform design decisions through the construction phase. So bringing in technology connectivity that improves the way that we build the network through connected autonomous plant, then into operations and maintenance. So enhancing the intelligent asset management approach, making better use of signs and signals on the network, automating signs and signals so that they can inform road users of the latest road conditions, and then into customer experience as well. So providing a better service into vehicles through satellite navigation systems, through other in-vehicle connected systems that allow that information to be passed to the driver for them to make more informed decisions on their journey. So moving to the next slide, hopefully that's transitioned across. Digital design and construction is the first theme under digital roads. So like I say here, this is about improving design and long-term planning, making it faster, more efficient, so use of automated design tools, move into a off-network, off-site manufacturing type approach, some modern methods of construction, whereby we actually take a lot of the work away from the roadside, move to a modular, standardized approach to delivery on the network, which means that the exposure for workers, the time taken to build schemes can be dramatically reduced. That standardization of components means that we can deliver things quicker to a standard type of asset, which also makes that maintenance and ongoing operational phase a lot more efficient. We can digitally rehearse, so we can test how things will be assembled on site through digital rehearsal tools. People going out there to actually physically build these schemes can rehearse those activities, get a proper understanding of what they're going to be doing when they're out on site before they get there. So big safety improvements through people knowing exactly what they're going to be faced with and doing once out on site. And then, like I mentioned, increased use of connected and autonomous plant moving forward for that on-site assembly approach. So again, it's making that better use of data. It's about using technology in the right way to enable certain outcomes. Certainly in the design and construction theme, this is all about reducing that network disruption to customers, increasing that productivity and delivery efficiency. And moving to the next slide, so digital operations and the vision behind this. So this moves us more into once the scheme's built, once we've got that technology scheme out there, how we make better use of sensors and the data that we get from that roadside asset to make more intelligent decisions around asset management. So get into a place where we're predictive rather than reactive, being able to understand when failures are likely to occur, and proactively getting out there to resolve them before it has an impact on the operation of the network. Making sure that planning across the network is better coordinated as well. So with the data coming back in, we can better understand how traffic will react to traffic management, to consecutive schemes, how we model the network in its entirety to make sure that the interventions that we go out and do are managed in the most efficient way. Then it's about making better use of the technology that we actually put out there. So using that technology to automatically set signs and signals when there are incidents, to use those signs and signals more strategically, so warning drivers well before they hit any form of incident ahead on the network. It's helping support strategic diversion routes so we can channel traffic and better adapt the network, make it more resilient to any issues that do arise. And then looking at how we provide better technology to workers so that we can automate workflows. We can get that data from the roadside back into the control centers in the most efficient way, providing more accurate information for the operators in control centers to make more informed decisions. And there's a number of opportunities around that we're exploring under the Digital Roads vision. And then finally, digital for customer. So the third of the themes. So this is about how National Highways as an organisation provide information to customers. Now, the number of opportunities here, there's the roadside assets and providing information to customers through roadside assets, all the way through to working with wayfinder services, so the likes of Google, Waze, satellite navigation companies, to provide that information into vehicles as well. Making that use of technology, but recognizing as an organization, they have limited sort of impact on the technology within the vehicle, but they have all the information that can be provided. So that collaboration in approach to providing that information to customers is absolutely key as part of the transition to digital roads of the future. And then looking at how we adapt the network to move towards an environment that will facilitate connected and autonomous vehicles themselves. So allowing the network to evolve over the next number of years to start to transition away from the heavy infrastructure type schemes that we're building and have built in the past, where all of the information is provided by roadside assets, to more of an approach where you've got that vehicle to vehicle, vehicle to infrastructure, or vehicle to everything connectivity enabled, so that the information from the network operator can be provided directly to the customer in their vehicle through the in-vehicle systems and the capabilities that are evolving through the whole CAV evolution. And then the final slide on digital roads, just to give you an idea. So those are some of the opportunities we're working on over the next 5 years. We're calling that the Digital Roads Platform. Digital roads, however, is a vision that takes us all the way through to 2050. So recognizes future trends such as, like I say, the connected and autonomous, ultimately, vehicle revolution that we're currently going through. But also how digital roads will act as an enabler to delivering a lot of the long-term ambitions that National Highways as an organisation have. So Vision Zero, reducing the number of fatal and seriously injured on the network down to zero, net zero and decarbonising the network through the use of the network, but also the way that they go about designing, constructing and operating the network as well. Some really difficult targets to achieve over that period, but certainly digital roads will support and enable those to be achieved through the opportunities that face us in the future. So hopefully that was a bit of a whistle-stop tour through digital roads as a vision. Like I say, we'll take some questions at the end, but I'd just like to move now on to part 2 of this presentation and start to have a look at how ITS can start to work towards decarbonising transport. So just setting a little bit of the context.
Tom, I do see that it shows that Annika's in the room. I don't know if she's actually here. So I don't know if you want to.
Oh, Annika, are you there? I'm happy to continue.
Maybe not. Okay, that's fine.
Yeah,
I'm sorry.
If Annika shouts up, then yeah, I'll pass over.
Okay, sounds good.
Perfect, thank you. So setting a little bit of the context. So I think, we're all aware that the planet is warming at the fastest pace we have in history, and CO2 emissions are really driving that climate change to levels that we didn't expect to see so quickly, and levels that really do put an onus on the global community to make a real change. And we need to make that change immediately, and we need to make significant decisions around our transport networks to get to a point where we are carbon neutral, and we hit net zero as a concept. Now, ITS has a key part to play in this, and we'll explore some of the opportunities in a little while to what that looks like. But just the graphs on the right-hand side show the scale of the challenge for the transport sector. So it's a significant contributor to global CO2 emissions. Somewhere in the region of 10 to 15% of all emissions globally come from transport. And what you'll find is that within the transport sector, a significant proportion comes from road transport. It's nearly 75% come from transport emissions come from road transport, which is a real challenge for us to face, and does paint roads in a bit of a negative light. Yet we recognise that road transport has a key part to play in the future of our transport networks. So the role of ITS. So where does ITS come into this particular journey? So I think what's been recognised over the last few years is that ITS isn't just about the technology. ITS is about the wider system, whereby technology plays a key part in the bigger picture. So as you see from the diagram on the right-hand side of the slide there's various components of the transport system that all need to be considered together, that all fit within this ITS banner. So you've got the people and the needs of people, and people really do drive the need for transport, and really how transport is shaped to deliver that what the customers really are asking for. The whole processes behind all of that, the place as well, and the context of the geography of that transport network, where people are needing to travel to, the reason why they're traveling to those locations, the location of work, the location of home, the location of friends really does influence the journeys and the types of transport networks that we create. Data, technology, and the vehicles themselves, and that ecosystem we look at from an intelligent transport system perspective. But what that does is enable, once you consider all of those elements, it really does lead to the ability for ITS to help influence travel patterns, influence demand, help reduce congestion, and facilitate more efficient planning, which ultimately leads then to safer and greener mobility for all. So when you put the two together, we looked and explored what aspects of the road to net zero ITS could most drive an impact upon, and really how we could use ITS to accelerate that decarbonisation approach. So the three key parts to where we saw ITS fit in, and it was about efficient use of existing transport networks. So really using ITS to adapt our existing networks to drive more capacity, to make sure that we were utilising the network in the most efficient way. And what that does is it starts to slow down the investment requirements needed for building new roads, which comes with all of that embodied carbon, and really has a significant carbon footprint when you start to use materials like concrete and steel. which most of our transport networks use in abundance. The second theme that we identified was modal shift, and how ITS had a key part to play in facilitating modal shift to public and more active modes of transport, which come with significantly reduced tailpipe emissions, zero if you get to active transport, certainly within our town and city centres. And then the final one, how ITS could play a role in the adoption of zero emission vehicles as well. So how it could support the electrification of fleet and other zero emission propulsion forms such as hydrogen and the like. And again, really contributing to reducing those tailpipe emissions. Just exploring each of those quickly. So we looked at how ITS could really play a part in efficiency. Key components of this was really using the technology to make sure that we could reduce congestion, we could keep traffic flowing. So in the UK, we have a concept called smart motorways. That's all about using overhead signs and signals to condition the traffic. So as traffic builds in the morning during peak periods, we're able to incrementally lower the speed limit to keep that traffic flowing a little bit smoother, should I say, allowing us to reduce headways so that vehicles are closer together. We can get more throughput on that existing section of network. So without the need for widening roads, building new roads, we can use more efficiently the network that we've got. And that does involve in utilizing what we call the hard shoulder, certain parts of the day, or even the hard shoulder permanently, and using that technology to ensure that we drive that network more efficiently, reducing the congestion, but done so in a safe manner. Another example, as you can see from the screen here, so some colleagues in Hong Kong have worked recently on a free flow tolling project. And what that enables is the prevention of vehicles having to stop at toll booth. The charging mechanism allows vehicles to continue to flow through the tunnel, and therefore what you haven't got is that stop-start traffic, the bottlenecks, the queues, and all of the associated emissions that are created when you've got a more traditional tolling approach to a particular section of network. And so ITS can really play a part by utilizing that technology to help smooth the traffic flow and really reduce those emissions from our road transport networks. If we then look at facilitating modal shift, to both public and active transportation, ITS plays a slightly different part in this particular area. So this is more around supporting our transport networks with applications, connecting customers with information. So for instance, having sensors on our bus networks that allow customers to understand where the next bus is in its particular journey, giving them confidence that the bus is on its way. Again, all of the information that provided at train stations around the location of trains, giving confidence to customers that everything's on time. And all of that information comes through applications that are part of that ITS, connecting that intelligent transport system together. Another one, mobility as a service. If we look at mobility as a service, we've got a lot of examples in the UK, but another example in Australia and New Zealand for some colleagues was creating a future-ready curbside. So actually using part of the road network to enhance the space that micro-mobility, so e-scooters and the like, could use, so that you had that shared space that was more attractive to move people towards active and mobility as a service type solutions. And space was created for like I say, the e-scooters, the bikes that are paid for on demand. And along with that came an application again that connected those people to that system, to that solution, that moved them out of vehicles into a more sustainable mode. And then the third theme around adoption of zero emission vehicles. So ITS plays, again, a slightly different part in this particular piece, and focuses more on information provision, and utilizing that information again to connect customers with the infrastructure that supports that reduced emissions. So in the Midlands, in the UK, we worked with Midlands Connect, who are an authority looking after the transport in its entirety across the Midlands, from public through to road transport. And we supported them with an electric vehicle charging infrastructure strategy. And part of that strategy wasn't just about the location of charging units for electric vehicles, but also how all of that information could be provided to customers in the most efficient way through ITS systems, be that roadside signage that would communicate the number of free bays that were available so that people could make more informed decisions on their journey, through to applications that allowed people to plan their journey in advance and plan that charging into their journey, be that at the end of the journey while they were at work, or part way through a journey if they needed a rapid charge, access to rapid charging technology, and kept them up to date and adapted their travel plans accordingly if more people were using those bays than was expected when people set off, etc. So quite a varied array of opportunities that ITS can play within this, from physical infrastructure on the roadside all the way through to applications that support mobility as a service. But what's most important is that it is the way that we apply this to our road networks. And we came up with a number of guiding factors that really recognize that the application of the technology isn't the complete solution. And as I mentioned at the start, there are other elements of the transport system that need to be thought about in its entirety for that intelligent transport to be treated as a system. So we look at applying the whole system approach. So the circular diagram that I showed you at the start, considering all of those components, allows us to make sure that there aren't unintended consequences when we apply a new technology, that we've thought about the needs of the customers, that the processes are in place, that actually it fits within the geographical context that we're applying to, hence the place, that the vehicles are adapted in a way that fits with that wider system. It's the right technology for the solution as well, the right technology that addresses the problem. And all of that, when it comes together, makes sure that the solution that's provided to that particular problem or challenge is the most applicable one, the most efficient one to drive the best outcomes. Second one was around adaptability. So, with technology, it changes at such a pace that we can get carried away with just applying the latest technology. Well, adaptability is a little bit more than that. So adaptability is around thinking how the life cycle of that particular system is going to work. And yes, it might be changing and enhancing the technology as we go along, but it's also recognizing that the needs of people will change as we go along. The context of the place will change as we go along. And that whole ecosystem is adapting and needs that constant review, again, as a whole system. And then finally, but arguably most importantly, human-centric solutions. So we really make it clear within the white paper that people need to be put at the heart of the solution. So there's no point in applying a technology that addresses a problem that doesn't actually exist, because that's not a challenge that people are facing. So it's really about getting under the skin of what people want, what people need, and adapting those solutions with people right at the forefront of that. And ultimately, when you bring all of that together and we use ITS and we think about it in the context of the net zero challenge, ultimately we can drive more sustainable outcomes. So that's my section done. I'll hand over to my colleague Axel for part 3.
Good, thank you, Tom. So the third presentation is around road safety and Vision Zero and the role that connected and automated vehicles have to play in this. So road safety, Vision Zero, that's sort of the third topic that WSP Transport and Infrastructure have for this year. So there are 3 key topic areas on which to do research and which to work and which to present. And I thought it was quite interesting when this was announced that this was alongside the 2 topics that Tom had just presented, digital and net zero carbon emissions. And Tom, if you go to the next slide, please, you will see, well, perhaps it's not as surprising when you look at some of these numbers, which when I put these slides together, I found quite astonishing. So you'll see here some figures for world, US, and Wisconsin as I could find them. First one is from a report from the World Bank and the Global Road Safety Facility. 1.35 million people die on our roads every year, and that was a staggering figure. I know there are 6 billion people in the world, but 1.3 million, that is just a phenomenal amount of people. According to Wikipedia, metropolitan population of Milwaukee is 1.5 million, so that's nearly entire population of the sort of greater Milwaukee metropolitan area wiped out in a year. It is the 8th leading cause of death of people of all ages, and the leading cause of injury and death for children and young adults. Now I have 3 children, and I thought that the most likely cause of them dying prematurely is they get run over on the way to school, on the way to a friend's house, on the way to football or soccer, probably as you would call it. It's quite a sobering thought. What I also didn't know until I came across this report and I put these figures together is that more than half of the global road traffic deaths are for vulnerable people. So it's not necessarily people in cars and trucks, but it's pedestrians, cyclists, motorcyclists who are most at risk from traffic and from us getting about to deliver goods and to go places, go to work, go on holiday, and so on. If you look at the figures in the US, they're obviously slightly smaller. Well, they're a lot smaller, but you're still having 38,000 people dying every year on the roads in the US. And if you think, well, that doesn't sound too big, the Department of Transportation was established in 1966, and since then, over 2 million people, 2.2 million, this is according to a report from a few years ago, so by now it will be more, but 2.2 million people died on America's roads since 1966. So again, that it all adds up to some quite large numbers. You look at roads in Wisconsin, so between 500 and 600 people. Again, you think that's a fairly small number, but that's still 1 or 2 people every day of the year dying on roads in Wisconsin. And what brought this home to me really is when I thought about this, we've got, well, I think just over 40 people attending at the moment, this session. And I'm fairly convinced that each one of you knows of someone who has either died in a road collision or has been affected by someone they know dying. And I've thought about myself, and I know of 4 people that I know or know of through connections that have died on the road. Two when I was sort of in my early 20s. One friend who died in a road traffic collision, got hit by a drunk driver head on. Another one who had drunk too much and came off his motorbike and killed himself. And then later on in my first job, one colleague lost her husband. When a driver didn't spot him, he was on his motorbike, driver came out of the side road, didn't see him. And she lost her husband, their daughter lost a father, and their unborn child never got the chance to know their dad. So this is, it's not just numbers. Numbers are staggering, but it's the personal tragedies that this causes, and that will impact people probably for the rest of their lives. Even those who weren't involved in the collision, that is the real tragedy here. And Tom, if you go to the next slide, please. What also struck me looking at these figures is we're not making progress. If anything, it's getting worse. If you look sort of the last few years, so this is figures from, you can't see, but it's from 1990s over the last sort of 30, 40 years here we're looking at. And yeah, the figures have come down from slightly over 40,000 to slightly under 40,000, but latest figures I could get hold of were for the first 6 months of 2021. So last year, and they were over 20,000. So unless a miracle happened in the second half of 2021, again, we're hovering around that figure, around 40,000. So continuing to do the same approach, the same way of designing, building, operating, maintaining roads the same way of designing, building and driving cars in particular is not going to get us anywhere near our vision of no one being harmed on our roads. So Tom, if you go to the next slide, please. So this is really the vision that 0 is the only acceptable number of deaths and serious injuries on our roads. I think in the past we have accepted that deaths and injuries are just part of going about. It's just unfortunate and regrettable, but we all need to go about places. We've got goods to move around, we've got people to move around, and unfortunately that means some people die in the process, and that's just the price we need to pay for our mobility. What Vision 0 does, it challenges that concept. So no, that should not be the price of our mobility. It's not sort of just be stuck at home or go out and risk being killed. My children shouldn't run the risk of being run over on the way to school. And Vision 0 says that is not acceptable risk, and we need to do whatever we can to achieve a transportation system that is safe. And what this requires is really a new approach, an integrated approach, and that's, I think, where intelligent transport systems can really help, bringing all these disparate parts together in a whole system approach. Tom, if you go to the next slide, please. So I've only got sort of 10-15 minutes, so I can't really talk about all these components. So I'll pick the one that is perhaps most promising or interesting, which is that around connected and automated vehicles. So this is from a report done in Australia, but it takes information from not just Australia, but from Europe, from the US, Canada, and other places as well. And really what I want to focus on with this slide is the numbers in the right-hand column. So the estimated reduction that some of these new vehicle technologies can bring, and they are quite high. We're not talking about 1 or 2% reductions. They can bring 20, 30, 40% reduction in crashes, and therefore also then in the potential of people being killed or seriously injured as a result of those crashes. And Tom, if you go to the next slide, there are similar figures then for some of these automated systems. So lane keep assist, autonomous emergency braking were two of the technologies that they looked at in particular. And again, sort of quite high potential for reducing collisions. So two more comments on this slide before we move on to the next one. And one is, while these technologies offer great potential, like with many things, we have to be careful because there can be disbenefits as well. So while they provide a great benefit, we have to be mindful that they can also have some disadvantage. We need to harness, I guess, the advantages and manage any downsides and any disadvantages that these technologies bring. What struck me, Tom, if you go to the next slide, what struck me, these two examples here, the lane keep assist and the autonomous emergency braking, in the SAE levels of automation, with sort of 0 being the least automated and 5 being a fully automated vehicle that drives itself anywhere in any condition on any road. We're only just seeing that transformation from levels 2 to 3. So the blue on the left, levels 0, 1, and 2, are the levels where the driver is still in control of the vehicle and in charge of the vehicle at all times. And these systems here, the ones I've circled, the lane centering, which is the lane keeping, and the autonomous emergency braking, they are really only level 0 and 1, but they do help. I've got them on my vehicle, and certainly the autonomous emergency braking stopped me from crashing into a car in front on 1 or 2 occasions when I wasn't paying attention, sitting in a traffic jam and not noticing the car in front of me had stopped again. We are just starting now to move to the level 3 systems. And why the level 3 systems have great potential, there's also some potential for things to go wrong, which is go back to the previous point here. So if we go to the last slide on this presentation, the automated lane keeping system. Basically, what this allows you to do, it allows a driver to perform what is called non-driving related tasks while the vehicle drives itself under certain conditions. So this is not everywhere, but particularly on motorways in traffic jams. So this is a great thing if you have a regular commute where you get stuck in traffic. So on your way to work, you're stuck in traffic for an hour. What this does is it can you can start addressing your emails, you can make phone calls, you can do all sorts of other things. On the way home, you can watch a movie rather than focusing on the driving task. There's, from a driver's perspective, great potential for this. But as you can imagine, there are also downsides, and there's quite a bit of research going on into this, particularly this system and this level where the car drives itself, but the driver still needs to take over control when the vehicle prompts it to do that. And one of the downsides, of course, is that the driver doesn't take back the control, or doesn't take it back immediately when prompted by the vehicle. And some of the research suggests that drivers leave it late rather than when the vehicle prompts them. They don't take control back at the earliest opportunity. They leave it to the last opportunity. And if drivers are anything like my children, that's not surprising, because if I ask my children to put whatever device they're on down to, I don't know, come to dinner, for example, it's just a sec, I'm just finishing this game. Oh, I'm just finishing this level. You don't put this, you're so engaged in the non-driving related tasks that you're doing. You're not putting this away immediately. You just want to finish reading this article or look at this video or do whatever you do. And there lies the downside risk. And the other risk that one of these studies from TRL, the Transport Research Laboratory in the UK, found is what they call the recalibration period. So drivers who have concentrated on something completely unrelated to the driving task take a moment, once they take control back of the driving task, so the braking, acceleration, the steering, to really adjust where they are. And this has led in some of the trials they've done on a simulator, hasten to add, not on a real road. They could really see people swerving all over the place and out of the lanes where they're in. So there is some potential dangerous driving going on in this, what they call the recalibration period, as the driver takes over and readjusts to being in charge and in control. And I can just turn to a quote from another report that Volvo Cars did a few years ago, where they looked at different alertness systems, whether just a visual warning or a tactile warning, such as a vibrating steering wheel, to keep drivers engaged with the driving task would be beneficial. And the interesting thing that they found in a nutshell was the better the automation, the less attention drivers will pay to traffic and the system, and the less capable they'll be to resume control. So again, this feeds into this. We have a system that potentially offers lots of benefits from a safety perspective, from a convenience perspective, but also has some downsides, particularly when drivers are asked to take control back. In some ways, it's the most difficult time, because the car does the easy bit, and then when the car thinks, oh, this is getting a bit tricky, they hand over to the driver who hasn't been paying attention for the last 5, 10, 20 minutes, and takes really some time to readjust and make the right decisions. A couple of other examples. GLOSA is green light optimized speed advisory. So this is where traffic lights basically or signal the vehicle to drive at a certain speed to hit the next green light. So this could be on an urban corridor, particularly in low traffic conditions overnight, so you don't have to stop at every traffic light and accelerate and stop again. In the UK, we're trialing this on motorway exits, where you then come to the next intersection, so that vehicles don't have to sort of stop as they leave the motorway, wait for a green light, and then move off again. They're trialing this at one of the biggest construction sites in Europe at the moment, a new power plant, nuclear power plant that they are building to make the flow of construction lorries, and there's several hundred of them every year and for the next few years. So again, from a point of view of emissions, fuel consumption, noise, a good thing. The downside is, in drivers, once they get used to it, they'll expect that the traffic light is green, and they may fail to stop at a red traffic light because they're not expecting it. And we've seen similar research being done on railways before, where train drivers just went past a red stop because your eyes tell your brain it's red, and your brain just filters out and says, no, it can't be red, it's always green, so you must be wrong. So again, lots of potential, but also some pitfalls, some disadvantages that we need to manage. And the final one is in-vehicle information, which again has got quite a lot of potential, providing driver with more relevant and timely information, for example, about roadworks, lane closures ahead, accidents, or debris in the road. And we can be more timely, more precise than we can ever be with roadside technology, signs that are in the verge. Downside of that, well, so another advantage, drivers might trust this information more than they trust signs that the roads authority puts up. But the downside, again, it needs to be the right information. It needs to be in a way that delivered in a way that doesn't distract from the driving task. So we'll need to make sure as we deliver this useful information, we don't distract drivers, we don't overload them with information, so they're more engaged with information we present, and they fail to look out of their windscreen and see what's going on ahead of them. So lots of potential for these as part of this wider system approach, but we need to carefully manage some of the potential downside risks of this as well. That's it.
Brilliant. Thanks very much, Axel. So I think we've got to the end of our presentation. So hopefully that gave you a little bit of an introduction to some of the key trends in the UK that we're working on, that WSP are embracing globally as well, around, like we talked about, digital, net zero, and vision zero. So just like to thank you all and open up for any questions.
So I don't see any questions yet. So I didn't know if you wanted to talk to a little bit about the transition period that it would take to get from here to like 100% of the vehicles being fully automated.
Yes, so that's an interesting one. If I start with this, Tom, I think a lot of people talk about we have sort of self-driving cars, by 2025. I think that is unlikely to happen. I know there are aspirations for it, but I think this will be very limited. I can see them in certain applications, sort of on campuses, for example, sort of autonomous pod type vehicles that drive at quite low speed. So if they get it wrong and they hit someone, particularly a pedestrian or cyclist, the damage is likely to be quite limited. But for me to get into my car, just put in, take me to, from Manchester back to Cambridge, and I go to sleep, or I'll do my emails or write a report, I think that's a way off. I was in a call this morning with BSI, the British Standards Institute, looking at standardizing some of these aspects of it. And one was around what do we do with emergency vehicles, for example? How does a vehicle react if it sees a police car or an ambulance or maybe a maintenance vehicle? There are so many variations in our driving. I think before we get to level 5 in particular, it will be some time.
I think just building on that, within the digital roads work that we've been doing here in the UK, we've recognised a transition period that probably looks quite infrastructure heavy at the same time as we're seeing quite quick enhancements and developments in in-vehicle technology. So I think the expectation is that we'll have to retain a lot of our roadside assets to make sure that safety critical information, travel information can be provided and understood and used by customers. Yeah. At the same time as a lot of vehicles will turn over and we'll get that connectivity in vehicle. I think there was a statistic here in the UK that it takes about 13 years for the turnover of fleet. So the new technologies that are coming on board today realistically won't be commonplace till another 13 years time because of the turnover in road road vehicles here. So there is a transition period, and I think it's really important that we think about that. We consider that within strategies moving forward, because I don't think there's a simple, you switch on a button and everybody moves to connected autonomous vehicles in the future. I think there's a lot of multi-layered approaches to come.
I think one thing to add, I think great potential. I see great potential in the in-vehicle information and getting information into people's cars that is more, perhaps trusted more, is more accurate, more timely. And the great benefit of that is everyone has that on their phone, so you don't need to buy a new car to get that. You can just download an app. If that's available, you can just download an app and get that information, or you can have an existing app that gets enriched with more and more layers of this sort of information.
Sure.
So I think that's in the short term probably the best. Tom, there's one in the chat which I think is probably for you.
Yeah, I don't know. Did you see that, or would you like me to read it?
Yeah, I can't see it, if you wouldn't mind.
Sure. As the digital side is expanding, how is design evolving, and how is change management affected in construction?
Good question. So certainly within the work we're doing here in the UK, we're finding a lot more automation filtering into the design process. So a lot of tools are being developed that will take data, take information around the context of the network that you're designing, and we'll take the design standards that we've got here in the UK that have been digitized now and are machine readable, takes those two components and creates an automated design from that. So that's certainly the way that design is heading, far more automated, with human intervention being the secondary part to that, whereby any challenges, any geographical constraints in the network that the computer can't deal with is moved to more of a human-led approach. Change management during construction, I think an interesting concept's emerging around progressive assurance. Now, what we mean by that is, rather than something's built and somebody comes out to site to inspect that, to make sure it's built to the right standards and assures that on site, we're finding that a lot of our connected and automated plant, connected workers, the technologies that they are using allows them not only to build more efficiently, but also capture information that supports that assurance process. So every time a piece of work's done, there's that reality capture on what has been produced, and feeds into a progressive assurance process, which ultimately, in the longer term, will feed into digital twins, will enable that digital representation to retain all of that live information as the asset improves and enhances through the construction process.
So one thought that went through my head as you guys were presenting was, as we move towards more automated or even 100% automated vehicles, do you see traffic numbers going down and traffic not being as big of an issue because they are all connected and they're talking to each other and they're pacing each other to make sure there's no bottlenecks, as you said?
Again, I think this could go either way, and I'm not quite sure which way it will go. I can see in one way we could be more efficient because I wouldn't necessarily need to buy my own car. I mean, we've got 2 cars as a family, and most of them, they just sit on the drive, or my wife takes one to work and then it sits in a car park for most of the day. And she drives it probably for an hour out of 24 a day, and my car, I'll probably drive for a couple of hours every week. So it's a huge waste of money I've invested in something that just sits on the drive. So if I could just have an app that hails me a automated vehicle and takes me to my destination while I get on with doing something else, that would be great. I think Tesla's already looking at this, where you, while you're at work and your car, instead of sitting in the garage or the car park, someone else can use this car and drive about, and it drives itself to wherever they need to pick this person up, and it picks them up, and it sort of is like an automated taxi that earns you extra money. So you have an asset that makes you money rather than just costs you something. The problem I see with this, the way we work in a lot of places is still very much, we all want to make the journeys at the same time. And so while in theory, if you could spread it out over 24-hour periods, you could probably use fewer vehicles. But because we all want to make journeys at the same time, I'm not quite sure. The other point, is one of the great benefits is that people who couldn't drive a normal vehicle, maybe because of a disability, for example, might be partially sighted, or they have a physical limitation that doesn't allow them to use a car. One of the great benefits is they could use an automated car because they don't have to drive. They get it's like a taxi without a taxi driver in it, or an Uber. That actually would then increase traffic because you now make journeys that previously you couldn't, which is good for the people in terms of inclusivity. But from the point of view of traffic, I'm not sure. I'm also wondering, I don't know how public transport is in the US. The perception is always that everyone drives, no one uses public transport. I'm sure that's not right. But traditionally Europe, continental Europe, probably even more so than the UK, people are using buses and trams and trains to get about. Certainly in urban areas, is there a temptation then if you get cheap automated cars that people want the comfort of their own little space rather than sharing a bus or a tube with lots of people, which is sort of uncomfortable, smelly, and perhaps not safe. So it could go either way. I think there are trends pushing you one way, there are other trends pushing the other. I don't know where we'll end up.
I think it's worth, as we've talked about through the presentations, it's that whole system approach that needs to be brought into this, because I guess there's no guarantees that the reasons why we travel now will be the same in 20 years' time. I mean, the COVID pandemic, probably the same in the US as it is in the UK, has pushed a lot of people to home working. So there's a lot of people that aren't traveling to city centres in the way that previously was done, and whether that trend will continue. I mean, we did see significant reductions in use of our road networks here in the UK because of the COVID pandemic, and I'm not entirely sure we've got back up to the pre-pandemic levels that we had. And it's whether some of these personal and people-based trends will actually drive transport down a whole different route. And when you consider it all in context, like Axel says, it could probably go either way.
I think, Tom, one good observation over the last decade probably is, certainly the UK again, I would imagine it's the same in the US and North America, in terms of what generates trips. It used to be in the UK, your Saturday trip to a big shopping centre, usually at the edge of a town or city, and you fill up with your groceries and all sorts of other things. That was a typical weekly trip that a lot of people would do. That's reduced quite a lot because you now get your groceries delivered to your door. So has that led to more trips or fewer trips? I don't know, because you still need to eat, you still need to get your food. It's just rather than you driving to the supermarket, a van comes to you. I don't know whether overall that's reduced or increased the mileage, whether it's made it more efficient or less efficient. I don't know. I'm not sure. But it's not necessarily reducing the trips, it's just replacing one type of trip with another.
Well,
it may be more efficient rather than 10 people going all to the supermarket and driving back home. Having one van delivering it to 2 people in the same neighborhood might be more efficient, but I'm not sure whether it's really that way or not.
Yeah, it'll be interesting to see how it all evolves. Just to speak real quick to what you had mentioned, and here in the States, you're right, all the urbanized areas, there is a lot of public transportation. The key is the last mile and the first mile. Those are the key struggles that we have throughout the US. But
that's similar to Europe as well, particularly when it comes to sort of goods that can't just easily carry. So some of my colleagues, Giles Perkins, one of our directors, has done a really good piece around rural areas as well, because a lot of this is around urban areas where in some ways this is perhaps a bit easier. But how do you do future mobility in rural areas where the default is the car? That's no different in rural areas in the US than it is in the UK. You don't have public transport. It's possibly more difficult with even automated vehicles because the roads are so much varied. So that's another interesting challenge, how we deal with those areas, not leaving them behind.
Well, I really appreciate your time today. Thank you for joining us from across the pond.
Thank you for inviting us.
Exciting to hear all the stuff. I'm going to encourage all the attendees that are still on, if you guys could click on the survey and give us your feedback, let us know what worked, what didn't work, and then we'll get a summary to you guys. But thank you again, and I will follow up individually with you guys.
Thank you.
Near
If
future.
there's any more questions, I don't know whether the chat was to be open, or I think their contact details to the
Yes.
conference.
Yeah. Reach out to
And,
us, and we can get you guys connected,
yeah.
or go through the app. You guys can.
Yeah. Brilliant.
Absolutely. Well, thank
Good.
you. Have a great
Thank you
rest
very
of your
much.
evening.
Thank you. Yes, thank you very much.
Thanks, everyone.
Bye.
Bye.
Bye.